Alright, here's our functions homework. So all we're doing is taking a look at these and determining if they are a function or not. Okay? So what I'm going to do is we'll go with a green check mark if they are, red X if they're not. So remember, there's three rules to a function, right? The first is, are there two groups? Okay, if we look at all these functions here, in points, there's two groups, the x value, the y value. Input, output, x, y. So 2 points, x, y, xf of x. 2 points on a graph, y and x. So all of these have two groups on them, don't they? Okay, so we're not really looking at that one. Okay, the second is there a pattern? Okay, in each of those, yes, there is some sort of pattern going on here. Okay, we may not understand it all the time, but there is a pattern. So really what it comes down to is that special requirement, that 1-to-1. Okay, that's what we're really looking at, trying to determine if that's where it's a function or not. Okay, so that's what we want to check on all of those. Okay, and remember what that means is for every input, okay, I know exactly which output it's going to. It can only go to one. So from one input to one output. Okay. Now, one input, remember, can go to the same output, but we can't have it going to a second one. That's when it gets bad. Okay, so let's take a look at these. So in points, what we're looking at is the x values to see if there's any that are the same. If there's not any that are the same, basically it's going to be a function. Okay, so 1, 5, 3, 3. Oh, see right here, two inputs that are 3s. Are their outputs the same? Nope, their outputs are different, so not a function. Okay, 5, 6, 7, 8. Yep, function. 1, -1, 0, 2. Okay, all go into 1. It's a function. -1, 3, 4, and 6. Again, it's a function. And the one down at the bottom, 0, 1, 4, 9, and 4. Okay, 2 4s. One goes to 1, one goes to 5. That's definitely not a function. Okay, now let's take a look at these Venn diagrams. So what we look for here is on the input side, do I only have one arrow going? And I can see right there that 3 has 2 arrows. That's definitely not a function. Okay, look at this one, 6 goes to 7. 2 also goes to 7, but that's still reliable. I know that's 1-to-1. 3 goes to 2. That's a function. Okay, over here, 5 goes to 6, -3 to 7. This 3 goes to 0 or -7. Definitely not a function. Okay, it's alright if the inputs go to the same output. It's not alright when it's the other way around. Okay, now this one, nothing goes to A, but that's alright. I'm just looking for the inputs. Okay, so there's all our Venn diagrams. Alright, so tables, again, scan here. If we see the same input with different outputs, not a function. Okay, different or same inputs, different outputs, not a function. Okay, that one, they can all go to the same output as long as they're different inputs. Okay, this one also good. Alright, 0, 1, 3, 6, that one's good. This one, 0, 0 to different ones, that is definitely not good. Okay, now for the graphs, a great way to do it is called the vertical line test. So you're basically running a vertical line across here, checking to see if that line touches it more than once. Okay, and that represents for the input having more than one output. So I look at this one, okay, if I run that vertical line test across, it checks off, so we're good. Okay, for this one right here, notice how I've got that right there. If I drew a straight line here, it would be touching twice. Okay, so that's definitely not. Same with this next one. It's an ellipse or an oval. Okay, it's definitely going to touch twice. Okay, this one right here, even though it looks like it's really close together, it actually never touches twice. Okay, so we've got all those ones good. So just these last few. Okay, down and then up, but if I run it across horizontally, it works. Okay, down, up, down, and again. Again, though, if I run up vertically, It checks off. Okay. This one is a vertical line. That's definitely not one. Okay, this one, even though it's a pretty horizontal down here and goes up almost vertical, because it's not vertical, it's going to be a function. Alright? Okay, the backside now is talking about discrete and continuous. So, the way to think about this is continuous is constantly growing. Okay, think of a sprinkler hose. Okay, if I have a hose here, not necessarily a sprinkler, and if I have water coming out, the water is continuously flowing. Okay, so when I look at these, what I look for in continuous isn't the arrows, it's if everything in between is connected. So, number 2, that would be continuous. Or number 2, or this first one. Okay, if I look at this one, doesn't matter if it loops down and up, it's got things connected, so it's continuous. Okay. When we're given just equations, okay, if I were to graph these, they would be lines. Okay. So every single one of those graphs, I'm going to assume is continuous. Okay. Now the opposite of continuous is discrete. Okay. The way to think about discrete is to think if I had a bucket of water. Okay. And I fill it up. Right? Fill up my bucket, and then I throw it in. Let's say we're filling up a little pool here. Okay? If I throw it in, I'm throwing in a chunk of that water from the bucket at a time. Okay? So discrete is working in that manner. Okay? Where it's not a straight line. So like this one would be discrete. See? There's points here, but there's nothing in between. Okay? With a table, knowing nothing else about this table, we're going to assume it's discrete because I don't see anything in between. Okay? So that's kind of the difference. So then when you're doing a story problem, that's how you have to think about it. So you and your friends go to the state fair. It costs $10 to get into the fair and $4 each time you go on a ride. Okay? So the question for continuous or discrete is, can I go in between? Can I do half of a ride? That doesn't make sense. Therefore, it's discrete. Okay. In Tooele, the average daily flow of sewage is 1,284,600 gallons. Okay. That one's going to be continuously flowing through. Okay. So that's continuous. Okay. In Tooele High School, there are 28 students in a class per day on average. Now, can you have a partial student? You can't. Therefore, it's discrete. Okay. So, there we go, guys. There's our discrete and continuous and some practice on whether things are functions or not. And there we go.